Greetings, this is Robin Way, the president of Corios. I'm going to present to you today the concept of closed-loop offer optimization, including some recent innovations we've developed to make that process work in real time. The business process looks like this: 5 simple steps, and it starts up at the top with monitoring customer behavior and performance. By comparing the issuing of offers and the responses of customers, you can predict the likely response to each offer in the future. These predictions can be packaged and deployed in real time so that you can score future customers for future offers. Next, you'll bring that information into an offer optimization scenario to allocate the ideal offers for all customers given the scoring that you've developed in the prior step. Finally, you can deploy those offer optimization scenarios also in real time, again down at the customer level. As you continue to refine and reallocate new offer strategies for customers, you'll continue to monitor the customer behavior and the performance of those offers in the field so that you can continue to improve the efficiency of this closed loop process. Let's take a closer look at the next step, which is monitoring customer behavior and performance. In this first step of the closed loop, we've got 3 detail steps. And we're going to start with step 3 actually in this process. We have to pick somewhere to begin. So let's start by preparing customer and offer data for the next predictive cycle. Let's start by examining a data file that represents historical responses to campaign offers. This data file provides a record of whether an account has responded to an offer, such as a mortgage offer or a retirement savings offer. It also has historical information at a snapshot in time about the account's credit attributes. This information is what we're going to use in the next step, where we start to build predictions of what will future customers look like who tend to respond to these kinds of offers. Now that we've assembled the customer and offer data for the next predictive cycle, let's move to the next step in the process. We're going to evaluate the best predictors for each response outcome. We're going to build a variety of challenger models to identify which model makes the best prediction, and we'll pick the best model and promote it as our champion. Here's a process flow that depicts how we're going to build our 3 predictive models for 3 different offers that we've sent out in the past. Here's that same set of attributes about customers that we looked at previously, and we can profile customers who've responded to different offers in the past, such as when I click on this bar here, it's going to highlight all those customers that have responded to mortgage offers previously. So at a moment's notice, we can get a visual profile of those customers likely to fit the profile of the customers we want to market to in the future. Now let's follow forward the model for our annual mortgage review. What we want to do is identify which attributes are going to be the most strongly predictive of future campaign performance. And this chart down here on the lower left-hand corner shows us which attributes are the most strongly predictive of retirement savings campaign response. So value, that's the value of their assets, has the strongest weight in this model. And it looks like from this chart up here in the upper left-hand corner that those with the highest asset value are going to be the most responsive to this campaign. That kind of makes sense. Let's actually evaluate that in the predictive model. And our predictive scorecard assigns points to customers based on their attributes. Okay, so we've completed this step of the process. Let's move on. We've predicted the likely response to each offer, and now we're ready to deploy these models in real time for each offer and each customer. We're going to take our champion models and save them as a scoring package. Then we're going to build a scoring routine for future customers and offers. And finally, we're going to evaluate the efficacy and validity of those models as the scoring routine. Now that we've created our model, let's package it up. Once they're in the metadata repository, we can do tons of things with them, like building a scoring routine. And this scoring package contains all the scoring code needed to calculate the final score. And when we're done, it produces an output data set. Let's take a look at what that data file looks like when we're done running those scores. So here's the customer ID. Here's whether they actually responded to that marketing campaign. And here's the predicted score that shows what the likelihood of them responding to the campaign in the future would be. This same scoring process can be used on any future data file that contains all the right characteristics of those customers. Once we've created those models and we register in the model inventory, we can also run reports against them. These are reports that Corios has built in order to validate the model's efficacy over time. Period 0 is the development period, but we can also monitor their efficacy over time, so that as model ages, we can see how much its efficiency falls off. Now let's move on to the next step, which is to optimally allocate the ideal offer for all customers. And again, this consists of 3 steps. First, we're going to assemble the scores for all customers and all offers for our historical offer optimization routine. And as part of that offer optimization, we're going to define the goals and the rules that will govern how we allocate offer strategies to customers. Finally, we'll build and evaluate a number of different offer scenarios, and we'll pick the best one as our champion. Let's take a look at that. So this is the tool where we're going to assign the optimal offer strategies to all of our historical customers. We've got 5 different kinds of offers: credit line increase, offering a second credit account, making a graduated card offer. That's, for example, upselling them on a more feature-rich card that offers rewards. Taking existing customers that are at risk of balance retention and offering them a retention offer, and those customers with a sales retention offer. Now, to set up the data, we've got 5 offers and we've got several 100,000 customers. And we have a row for every single customer, and we've got scores for each of the 5 offers. So here's scores for 5 of the offers that we'd make through the website and 5 offers we make through the call center. So we've differentiated likely response scores by which offer and by which channel they're going to be offered. We also know how much they're expected to contribute in terms of NPV for the next. We're also concerned with contact policies. So we've got a count of the number of times that each customer has visited the website over the last week and over the last day. And we've got customer attributes such as, are there any additional borrowers? How many trade lines do they have? What's their utilization percentage? What's their FICO score? So we're going to use all that information in order to assign offers to customers, and we have several rules we're going to follow. The first set of rules we're going to assign are suppression rules. These are sort of like eligibility rules, except they work in reverse. So for example, for credit line increase, we want to make sure that we can assign those offers to those customers who do not have additional borrowers, where their utilization percentage is over $35,000. For the second offer, which is assigning a second account, well, the first thing we want to make sure that we do is make sure that they have more than one borrower in their household. And we want to make sure that they have more than 3 credit trades and a relatively high balance. Second kind of rule that we have are objective functions. So we're going to maximize the net response, net present value. A third kind of rule is our offer constraints. We can only make 3,000 offers through the call center on each day. So this rule here, maximum offers through CC1, that's our call center code, per day is 3,000 in each time period. And to define that rule, we typed in those values here, and then we said if the channel code is CC1 and the time period is T5, then the most we can make is 3,000 offers. So all of those constraints are rules that govern the allocation of resources to sending offers out the door in the aggregate. We also have bottom-up rules like contact policies, and these determine how many offers each individual customer can receive, either per time period, per offer, a combination of the two, as well as rolling offers over time. So for example, this one says each customer can only get at most 1 offer through the call center per day. But this here says they can only receive 1 credit line increase offer every 4 days. And so that's a rolling contact policy. Very powerful. Here's an example of a chart that shows the comparison of offers across the 3 different strategies. In this one, we're going to be sending out more offers of the second account, more offers of the graduation offer, and slightly fewer of the retention offers compared to the second scenario. The dollar figures for the second and third scenarios are actually quite close, but they're larger than for the first scenario. By comparing and contrasting these various combinations of rules, we can pick the champion scenario we want to promote. And that's the third scenario. So now let's create a batch program and promote this program to be run as our champion scenario. We finished training our offer optimization strategy to assign the best offers to each of our historical customers. Now we're ready to start deploying it into real time for future customers. Deploying real-time offer optimization for every customer consists of 3 steps. First, we're going to learn from what we used in our champion strategy to build a scoring routine for every optimized offer. Then we can apply those new offer scorings to every new customer on demand. And finally, as part of the closed loop, we want to evaluate the efficacy of those real-time optimization scores to make sure that it's working just as well on new customers as it is working on historical customers. Okay, now we're ready to package up the optimization model that we promoted as a champion and set up the scoring routine. So we're going to start with the MO project that we had before, SMM C1P. We're going to pick the right scenario that was our champion. And we're going to simulate both the sending out of offers in future time periods as well as their likely responses from customers. Where we've already run offers for 4 prior time periods, and we're going to start in time period number 5. And we're going to run for 3 future time periods, 5 through 7. Now let's change things up a little bit and estimate that our email response rate will actually be 30% instead of 40%. And let's imagine that our call center contact rate is, instead of 80%, it's actually 70%. When we're done, we'll have 3 time periods of optimized offer allocations and responses that we'll be able to use to our scoring process. Let's run it now. Okay, the process is done, and here's the results. So we set it up to run for 3 time periods. Here's the number of offers, the expected MPV, the web impressions, the contacts, and the responses. It also shows us a breakdown of the same metrics across the channels, the call center, email, and the 2 websites. Next, let's deploy our champion optimization scenario and get it ready for running in real time. To do this, Corios has designed a specialized process. When we run this, it generates an enterprise miner series of 20 projects, 1 for each offer and channel. This is an example of an enterprise miner champion challenger process that we built in lights out mode. We can see when we click on the history that the last time it was updated was on the 9th of October. Now we're going to actually run it in real time and generate the updated results for the most recent set of model scenarios. Let's run this process in batch. This takes a few minutes, so I'll come back as soon as it's done. Great, the job just finished because I received an email from the automated system letting me know that the job finished at 3:30 in the afternoon. So let's go take a look. So here's that same enterprise miner project we were looking at earlier. Let's open up this diagram and look at its history. And sure enough, at 3:20, this job started getting updated and has an updated set of results. I've got a summary data file that contains all of the runs for each of the 20 model scores all contained in one file. And it keeps appending every time we update the champion MO model. So here's the date timestamp, here's the customer ID, then here's all the 20 scores. If we go down to the very bottom of the file, here's the job that we just ran at 3:30 in the afternoon. And let's open that up in Jump so we can actually visualize the changes in the scores over time. So we can see as we've changed the conditions on the underlying model and the underlying champion optimization routine, the distribution of the scores has changed. If we insert a different score, again we can see that each of these columns of whisker plots is showing the distribution of the scores, and they keep changing as the model keeps getting updated. Here's another one. So when we modify each of these optimization routines over time, they're learning from the updated champion model and the updated modeling conditions. Okay, so we've set up our optimization routine to run in real time, but we haven't actually tested it yet. We're going to use Salesforce.com as the approach for testing our real-time optimization routine. We've deployed those scoring routines on the back end of the offer optimization strategy as web services and open them up in Salesforce.com. So we've got a customer named Brian Gates, and he's got a number of attributes that describe his credit information and the loan that he's applying for, which is exactly the same information we used on all the predictive response modeling that we used on the front end of the offer optimization. So now we can run this real-time query to identify what kind of offer would we make for him when we're actually interacting with him in real time. In real time, we'll get back, here's the top 3 scores for him. He's got a 26% probability of responding to this mortgage offer. He's in scorecard bin 9 and 118 scorecard points. But what if we ran a new credit report on him right now and found out that actually his financial outlook isn't quite that rosy? He's actually got a 70% debt to income ratio. He's got 6 delinquencies and 2 derogatories. He's actually only been in his current job for 6 years. Let's rerun his real-time offer optimization. Now his probability of response for the mortgage has gone down and his scorecard points have changed. So we can see that there's a real effect on which offers are the right offers for him, depending on what his attributes are. We've been taking offers for retirement account, mortgage, and annual mortgage review, and we can see over here on the left what their profitability is per different optimization scenario. So we've got profit per response over here for different kinds of offers, cross-sell and credit card offers, and we've also got number of responses expected for each scenario. And right now we're looking at all three campaigns, but if we looked at just retirement campaigns, we can see that the profitability for those scenarios goes down quite a bit, whereas if we're focused on mortgage, they're quite a bit larger. So that pretty much wraps it up. We've gone all the way from monitoring customer behavior and performance through developing new response likelihood prediction models, deploying those to the offer optimization routine, building the offer optimization routine, and then deploying the real-time offer optimization out to Salesforce.com. If you'd like to learn more information about how Corios has developed this specialized process for offer optimization, give us a call. Have a great day.